Okay, in the next three sections, we're going to look at polynomials and finding zeros of polynomials. I'll explain that. Um, we're going to need to do a lot with polynomial division, though. So they have a section on polynomial division before we get to other things with polynomials. For example, suppose that we divide a polynomial by a monomial. Okay, suppose that we have 5x to the fourth minus 30x squared plus 3x divided by 15x squared. Okay, the first thing that I'm going to do is, and I've got a monomial. Monomial just means that you have one term. The first thing I'm going to do is I'm going to divide this polynomial by this monomial by sticking the monomial under each one of the polynomial terms. Okay, so I got 5x to the fourth minus 15x squared minus 30x squared divided by 15x squared plus 3x divided by 15x squared. 5 over 15 is 1/3. X to the fourth over x squared is x to the fourth. X squared is going to cancel there. 30 over 15 is 2. Plus 3 over 15 is 1/5. X over x squared is 1 over x. So 1 over 5x. And that's as far as I can take this. Okay? So dividing a polynomial by a monomial is not so bad. All you do is take the monomial and write it under each one of the terms for the polynomial. So before we look at division for polynomials, let's go back to just basic division and remember how that goes. Suppose that I want to divide 175 by 3. Okay, the 3 is going to go outside the division bar. The 50, think of how many times 3 goes into 17. Okay, 3 can't go into 1. So 5 times. 5 times 3 is 15. 17 minus 15 is 2. And bring it on the 5. Now look at how many times 3 goes into 25. Well, 3 goes into 25 24 times. I've got 1 left over. 1 divided by 3 is 1/3. So 175 divided by 3 is 58 1/3. Okay. Now this same approach is a very similar approach is what I want to do with dividing by a polynomial. Okay. So let's take a look at 2x squared minus 5 plus 5x minus 3 divided by x plus 3. Okay, whatever expression is in the denominator is always going to go outside the division bar. The expression in the numerator is going to always go underneath it. So you got 2x, and I want to think of an expression such that the leading term, so what times x gives me 2x squared? Well, it'd be 2x. 2x times x gives you 2x squared, leading off. Plus 6x. And just like with numbers, I want to subtract. 2x squared plus 5x minus 3 minus 2x squared minus 6x. 2x squared minus 2x squared, those are gone. 5x minus 6x is negative x, and I can bring it on the minus 3. So now I'm looking at how many times x plus 3 goes into negative x minus 3. Well, I can do that negative 1 times. Negative 1 times x plus 3 gives me negative x minus 3, which I'm subtracting. That would leave me with a remainder of 0. So I think that when I divide 2x squared plus 5x minus 3 by x plus 3, I get 2x minus 1. To check that, I can take 2x minus 1 times x plus 3, and I can hopefully I get the what's underneath there. Okay, so if I take 2x minus 1 times x plus 3, and I FOIL that, 2x times x is 2x squared, 3 times 2x is 6x, minus x is 5x, and then negative 1 times 3 is minus 3. Well, that's exactly what I get underneath the radical. Okay? Suppose that we have 12x cubed minus 14x squared plus 7x minus 7 divided by 3x minus 2. Okay? Well, the 3x minus 2 goes outside the division bar. 12x cubed minus 14x squared plus 7x minus 7 goes underneath it. And I'm going to begin dividing. So I'm looking for an expression such that when I multiply by 3x minus 2, the leading term gives me 12x cubed. Well, that's going to be a 4x squared times 3x, 4x times squared times 3x, it gives me 12x cubed, minus 8x squared, and I'm subtracting that whole thing. So 12x cubed minus 12x cubed is 0. Negative 14x squared plus 8x squared gives me negative 6x squared. And I can bring down the next two terms. I get a minus 2x times 3x minus 2 gives me negative 6x squared plus 4x. Okay. I'm subtracting that, so I got to switch all the signs. And negative 6x squared plus 6x squared gives me 0. 7x minus 4x gives me 3x. Bring down the minus 7 there. And then a plus 1. So I get a 3x minus 2. 3x minus 7 minus 3x minus 2. Okay, 3x minus 3x is 0. Negative 7 plus 2 is negative 5. Okay, here's where I got a remainder. And the remainder always gets added to my my quotient, is what it's called. The complete leftover information is plus negative 5 divided by 3x minus 2. You always take the remainder over the divisor, 3x minus 2. Okay, and that's going to be your leftover. So, 12x cubed minus 14x squared plus 7x minus 7 divided by 3x minus 2 equals 4x squared minus 2x plus 1 plus the remainder, which is negative 5 divided by the divisor, 3x minus 2. Okay, so here's what I'm trying to explain. Whenever you take the dividend over the divisor, okay, which is what these two terms are called, you just get a quotient plus a remainder divided by the divisor. Okay, write your answers in this form. Okay, now the book will take this a step further, and they'll clear out the fractional form. There's no reason to do that. No reason. Okay, I see what they're trying to do. They're trying to give you a preview to what's coming up later, but there's no reason to be doing that. Okay, so if you were to give the answer as in the book, by clearing out the remainder, multiplied by 3x minus 2, I'll go ahead and group the first three terms together, and I'm multiplying by 3x minus 2. Then I'm in the form dividend equals divisor times quotient plus remainder. Okay, it's okay if you want to give the answer in that form. I guess pay attention to the wording, but it's okay if you give the answer in this other form though. Okay, so for example, suppose that we got 2x cubed plus 7x squared minus 5 divided by x plus 3. The x plus 3 is going to go outside the division bar. 2x cubed plus 7x squared minus 5 is going to go underneath it. I'm going to leave a gap between those last two terms just because I want to make sure all my columns are lined up there. And I'm going to divide. 2x squared goes into x plus 3. 2x is 2x cubed times plus 6x squared. And I'm subtracting that. So 7x squared minus 6x squared gives me x squared. Bring in the minus 5. And I'm going to look at how many times x plus 3 goes into x squared minus 5. That's x times x plus 3 is x squared plus 3x. And I'm subtracting that. X squared minus x squared is 0. 0 minus 3x is negative 3x. I can bring in the minus 5 there. Negative 3x minus 5. Okay, so negative 3 is what I want there at the end. Negative 3 times x plus 3 gives me negative 3x minus 9. Negative 3x plus 3x is 0. Negative 5 plus 9 is 4. Okay, 4, I'm done dividing now. And so I'm going to have a remainder over a divisor. Plus, and by the way, a mistake that I will always see, or not always, but pretty regularly see, is that a student will forget to write a plus sign. Make sure that you remember to do that. Okay, make sure that you remember the plus sign. So plus, the remainder is 4 over the divisor, x plus 3. 2x cubed plus 7x squared minus 5 divided by x plus 3 is equal to 2x squared plus x minus 3 plus the remainder is 4 divided by the divisor is x plus 3. And so that's what I want in your answer. Okay, if you were going to write it as how the book wants it, then you basically clear out the fractions on both sides, group the leading terms together there, the leading 3 terms, and multiply by x plus 3, and we got the remainder left over. Okay, now there's something called synthetic division, which is a shortcut for dividing a polynomial by a binomial. 2x cubed plus 7x squared minus 5 divided by x plus 3. So I already know that. Okay, I'm just redoing that problem again, but by using synthetic division. The first thing that you want to do is you want to take the number that causes 0 to happen in the denominator. We call that the 0 of the denominator. Okay, that's negative 3. And negative 3 goes in the upper left-hand corner in this box. I write the quotients to the right of that. So I got a 2 in front of x cubed, a 7 in front of x squared, a 0 in front of x, and then a negative 5 at the end. Never ever skip terms. Okay, so we've got a 0 in front of x. Okay, we must have the 0 in order to get the right answer. To begin dividing, I bring down the quotient, 2, and then I take 2 times negative 3, which is negative 6. 7 times negative 6 gives me 1. 1 times negative 3 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is 9. Negative 5 plus 9 is 4. 4 we usually, you might see a vertical line to the left of that. You don't need to have that if you don't want. But in this bottom row, we end up getting the answer, which is 2x squared plus x minus 3 plus the last coefficient is the remainder. And so plus 4 divided by x plus 3. Well, that's the same as what I got over here. Okay, so In general, synthetic division, I believe, is a quicker option for dividing a polynomial by a monomial, or by a binomial. Now you can only divide a polynomial by a binomial to make it work. Okay, so there is a condition on the division part. If you're dividing by anything other than a binomial, synthetic division does not work. Okay, does not apply. So we got to make sure that we have a binomial in the denominator. Okay, the reason why it's quicker than long division is because on long division I'm writing x each time, and I'm not doing that here. I'm only using the coefficients in dividing. Okay. The last thing in this section is something that's going to be used heavily in the next two sections, which is called the remainder theorem. And it says that if a polynomial f of x is divided by x minus k, then the remainder is f of k. Okay, so let's take 2x cubed plus 7x squared minus 5 for f of x divided by x minus k. So negative 3 is the 0 of the denominator. Okay, now I should get the remainder. Check it out. If I take f of negative 3 cubed is negative 27 times 2 is negative 54, plus negative 3 squared is 9 times 7 is 63, minus 5. 9 minus 5 is 4. And 4, yeah, that's exactly what I get there when I divide regularly. Okay, just for some practice, suppose that I take f of negative 1. Okay, f of negative 1 gives me 0 because negative 1 cubed is negative 1 times 2 is negative 2 plus 7 is 5 minus 5 is 0. This means that x plus 1 is a factor of f. X plus 1. So whenever you get 0 as the remainder, the input number is a factor of f. Okay, so this means that x plus 1 is a factor of f. This right here, because I did not get 0, means that x plus 3 is not a factor of f. Okay, so that's kind of a preview to the remainder theorem. We'll be talking about that quite a bit in the next two sections, actually. Okay, the homework is on page 298. Be sure to look at those problems for me when you get a chance.